Okay, 3-2 homework help is, the first problem is it wanted me to just have to FOIL this out and find the coefficients of this polynomial. So we're going to be dealing with polynomials of higher degree today. This is a third degree one right here. And to find it, we just FOIL. So first times first gives you x squared. Middle terms would be negative 7x and 3x, which makes negative 4x. And the last terms would be negative 21, the last term. And then we still need to multiply that by x minus 10. And so first times first gives you x cubed. First times second is negative 10x squared. Negative 4x times x is negative 4x squared. Negative 4x squared times negative 10 is positive 40x. And then negative 21 times x is negative 21x, and negative 21 times negative 10 is a positive 210. Now we can simplify this to add the x squareds together to get negative 14x squared, and add the x's together to get positive 19x plus 210. And so your coefficients are 1 goes right here, negative 14 goes right here, 19, and 210. Okay, the next problem then is just a problem that tests our vocabulary and makes sure we know what these are called. So we're looking for a quartic binomial, which is a fourth degree polynomial with two terms. All right, so the last one, if you distribute this becomes x to the fourth minus 2x cubed. So that's a fourth degree polynomial with two terms, that'd be e. A cubic polynomial would be, if I FOIL out d, I'd end up with x cubed plus something, and that'd be a cubic polynomial. That'd be d. The square of a cubic polynomial, that'd be a 6th degree polynomial. You know, if you had some cubic polynomial, like a real simple one like that, and we squared it, so we multiplied it by itself, you'd end up with a 6th degree polynomial. So that'd be a. Quintic binomial is a 5th degree polynomial with one term, that'd be b. And then a trinomial would just be what's left over with c. If you FOIL this out, you would get a trinomial. So basically, when you have a polynomial, then the degree is if you put it in standard form, 6x to the 8 plus 4x minus 6, the degree is the highest exponent, which in this case is 8, and the leading coefficient then would be 6. Okay, so another problem that tests that information then is this one. We don't have to FOIL this whole thing out. We could actually just look at the x's. So I'm going to FOIL the first two, but just look at the x's. So the highest degree, basically. So negative x times x gives negative x squared, right? Now I don't care what the rest of it is. There's going to be some more there, but I'm going to eventually multiply it by 7x plus 2 squared. Well, when I do the 7x squared, I'm going to end up getting 49x squared. And so I'm going to end up multiplying this negative x squared times negative 49x squared. That's going to give me negative 49x to the fourth. So I don't care about FOILing out the rest of it. I just care about the degree, basically. So the variables with the highest exponents, multiplying those out. So this degree would be a fourth degree. The leading coefficient would be negative 49. And the constant coefficient then is just the numbers. So I'm going to do the same thought process with just the numbers. So 4 times 2 gives you 8 here. Would be last. And then here, 2 times 2 will give you 4. So the last one would be 4. And when I multiply 4 times 8, it gives me 32. Okay. Next problem then gives us a third degree polynomial. And we want to talk about how many local maximum and minimum it has. Well, third degree polynomials we know look like this. So we know that there's one local maxima and one local minimum. And you know, I don't know if it wants 1 or 2, I don't know the way this is worded, but it has 2 local maximum and minimum, it's got 1, 2. And the total number of local maxima or minima is always 1 less than the degree of the polynomial as well. So the next problem then gives us a 5th degree polynomial we can see here. So it's got up to 5 real zeros. And then asks us some questions. The graph of this function shows how many relative maximum, that'd be 1, 2. And 1, 2 relative minimum. The total number of 4 extrema. The graph is increasing on the bounded interval from, so it's looking for just the bounded interval that's increasing. So that'd be from 0 to 1. It's increasing there. And that's the bounded interval. So we would say from 0 to 1. Okay, next question then has to do with symmetry. We got a fourth degree polynomial if we multiply this out. Looks like it has zeros at -2, -1, 1, and 2. Is this equation symmetric to the x-axis? No, because like this point, for example, would have to be down here, right? Because you know that symmetry is when every point can be reflected over the line of symmetry to land back on top of itself. So that's no. Is the equation symmetric to the y-axis? That's yes. Every point can be reflected over the y-axis to land back on top of itself. Symmetric with respect to the origin? No. That would you'd have to rotate this thing 180 degrees, land on top of itself. In which case, this point would be rotated 180 degrees to land on top of itself, which it doesn't. So no. Next problem gives you a fifth degree polynomial with a positive coefficient starting. So we know this thing looks something like this. It could have up to 5 real zeros. And it just asks about the end behavior. So it says, what happens to the y value as the x value goes to -infinity? Well, it goes to -infinity down here. And then what happens to the y value as x goes to positive infinity? That goes to positive infinity. Next question, similar, wants to know the degree of the polynomial from the following, the smallest degree. Well, this thing could have up to 1, 2, 3, 4 real zeros, so that's a fourth degree polynomial. It could have other, we don't see the whole graph, so it could have more, but the smallest possible degree there is 4. In fact, it does have 4 real zeros according to this graph. All right, next problem then gives us this polynomial here. Now, we know that when we multiply these out, we're going to get a third degree polynomial because there's x times 3x times -x basically as the leading term. So degree is 3. The number of terms, if you remember the first problem we did, we actually FOILed this whole thing out. We end up adding like terms. We end up with 4 terms when we simplify, because you have x cubed plus something x squared plus something x plus a number. So there's going to be 4 terms. I don't know what these coefficients are, but that doesn't matter. The other thing is we can look at the first term. So when we multiply x times 3x, we get 3x squared. And we multiply that by -x, we get negative 3x cubed. So when we just look at, FOILing through the x terms, we're going to end up with a leading coefficient of -3. That means it starts up and goes down like this. And it can have up to 3 real zeros, but we know that as x goes to positive infinity, y goes to negative infinity. And as x goes to negative infinity, y goes to positive infinity. Okay, the next problem gives us a fourth degree polynomial. It wants us to estimate the zeros, so we're going to use decimals for this. You can, on some of these, you can highlight it and Control-C, copy it to decimals, which will save you some time. So I recommend trying that. And it looks like we got 2.718 and 3.702 as our 2 real zeros separated by a comma, which is what it wants. I don't think it wants the imaginary zeros here. No, the real zeros should do just fine. Next problem is pretty straightforward. It wants the minimum value of this fourth degree polynomial. Once again, copy and paste this into decimals if you can, and then you got to find the minimum. So we're going to scroll out and down until we find this. And it wants 3 decimal places, so we are going to have to zoom in a bit in order until we get 3 decimal places here. So I guess here this will do fine. You can see that this it's at negative 3/4, negative 0.75, comma negative 15.543. The next problem is kind of a different question. It says, which of the formulas below could be a polynomial with the following properties? Its only zeros are at -8, -2, and 4. So those got to be factors, basically, which it looks like all of them have these factors, I think. Well, maybe not. Some of them might not. But it has a y-intercept at 4. That means that when you plug in 0 for x, you should give 4 for y. And then it goes to negative infinity as x goes to positive and negative infinity. So basically this thing has to open down and be a fourth degree polynomial then, because otherwise if it was odd, one branch would go up. So it has to be an even, overall it has to have an even degree, and it has to open down, so the first coefficient has to be negative. So we can get rid of this first one, or the last one I mean, because there's no negative there. We can get rid of any ones that are odd. So like this one's fine because it's got x times x times x times x would be a fourth degree polynomial, so that will go down. Both branches will go down if this is negative. The problem is this one has a 0 at 0, and that's not one of our zeros, so that's not one of them. Let's look at this one. Negative 8, negative 2, and 4 are all zeros. That's good. This thing opens down. That's a third degree though, so that doesn't work because one of the branches would go up. Okay, in fact, it looked like this. So that doesn't work either. This one's negative, but it's a third degree polynomial again, so that doesn't work. We need a fourth degree, and we need an even polynomial. So 4, 5, 6, this has 6 degrees, so that would work. The zeros are at negative 8, negative 2, and 4, and this opens down, so this would work just fine. This one's 2, 3, 4, this is even. The zeros are at negative 8, negative 2, and 4, so this one works just fine, opens down, fourth degree, so that one's good. And this one's good as well because it's got zeros at negative 8, negative 2, and 4, and it's a fourth degree polynomial that opens down. So it looks something like that. Okay, the next problem wants to give us a fourth degree polynomial that matches this function. This thing goes through negative 3, 0, and 3, so we've got to have zeros there. So we've got x, x plus 3, x minus 3. Now this has to be x squared because whenever a function touches and turns around, it's got an even power. It's got a multiplicity of 2, which means even power. So we know that it looks like this. You could go x to the fourth, but not in this case because they want just a fourth degree polynomial, so this has to be x squared. There is some a term still to this polynomial, and I don't know what that a term is, but I can find it by plugging in the 0.5, negative 120. Plug in negative 120 for y, and plug in 5 for x. This would be 25. This would be 8, and this would be 2. Now multiply these out and divide, and you get an a of negative 0.3, or it's a fraction, negative 3 over 10. So that goes right here. And here's your polynomial then. And they want f of x. So just enter in this part right here. Okay, this is the same type of problem. Our factors, they give us some zeros, so here's the factors. And they want it to be a cubic, so third degree, that works fine. It's got to go through the point 1, negative 1. So I get to find my a value then by plugging in 1 for x and negative 1 for y. So this would be 3 times 2 times negative 7. Okay, once again, if you solve this, you'll find your a value, which is 1 over 42. That goes right here. And this is f of x, not y. So enter in that, and you're good. Last problem is similar, but this time it's fifth degree. Leading coefficient is 1. It has roots of multiplicity of 2 at x equals 1, so that'd be x minus 1 squared. And x equals 0, so that'd be x squared. And then it's got a root multiplicity 1 at x plus 4. So then the leading coefficient's 1, so they gave us our a value. It has to be 1. So there's our polynomial. They call this p of x. And that would be just fine if you type this in. All right, hope this helps.